Hello viewers, welcome back to my channel. I hope you are enjoying all the videos that I am uploading. If you haven't subscribed to my channel yet, please go ahead and subscribe to my channel and also share among your friends. Today's problem is find a corresponding node of a binary tree in a clone of that tree. So basically we are given with two binary trees, original and cloned, and given a reference to a node target in the original tree. The clone tree is a copy of the original tree. Return the reference to the same node in the clone tree. Note that you are not allowed to change any of the two trees or the target node. That answer must be a reference to the node in the clone tree. So basically we are given with two identical trees called original and clone, right? And we are given with a target node in the original tree. So we have to return the corresponding node in the clone tree. So the problem sounds pretty simple. Let's go ahead and look at the example, right? So these are two identical trees, the binary trees, and they have nodes 7, 4, 3, 6 and 19, right? And the target node that we are given is 3, so which is highlighted in the green color, right? And our task is to find the corresponding node, the 3, in the cloned tree, right? And return that corresponding node, right? It's pretty simple for that, right? So depending on the tree size and the level at which it is, you will have to go traverse through all that and then try to find out the similar node. So what we are going to do here is we are going to do the traversal on both trees simultaneously, right? So parallelly we are going to traverse original tree and clone tree and look for the target. So if we find the target in the original node, right, the corresponding node at which we are, that will be the node in the cloned tree, right? So the basic idea is very simple. We are going to traverse both trees in the same manner. That means if we go on to the left subtree in the original tree, in the same way we are going to go through to the left subtree on the cloned tree also. Similarly, if you are going to the right subtree on the original tree, go on to the right subtree on the clone tree. So if you traverse in the exact same way, right, wherever you encounter the target node, right, the corresponding place in the cloned node is the target, cloned target, you could say, right? Clone target, right? So that's the idea, right? So what we are going to use here is we are going to use a BFS traversal, breadth first search traversal of the tree for this, okay? And we will hold the pointers to the node in the original tree and the pointer to the node in the clone tree. As I said, these pointers will be used to traverse through the entire tree, right? So just to keep track of the original node and clone node together, right? So I have created a class called a node, right? So the given class is a tree node, so that is a tree node, which is a binary tree node. I am creating a node class, so which will have references to the node in the original tree and node in the cloned tree, okay? So at each level, right? So we will go through this node and try to find out the node, right? So wherever we find out the target, right, the corresponding cloned node, right, will be the answer for that particular thing. So as we are using BFS traversal, right, naturally we will have to employ a queue since I am doing in the iterative manner, right? So let's go ahead and apply the same logic that we have discussed to the code. So if we go look at the code, right, so let's go look at here. These are the first things first, right? If original tree is null or clone tree is null or target is null, you just go return null, right? So if any of them is null, that means you didn't find, just return null. So if original is equal to target, right, that means basically you are given the pointer to the root node, right? So original is a root node for the original tree and cloned is a root node for the clone tree. Target is the just a reference to the target node. That's it, nothing else, right? So what we are going to do here is, if at all original is equal to target, you just return the clone. That's it. You don't have to go further. These are just to minimize the steps and all, right? So these are the basic stuff. And then if we have to traverse through the tree, right, just create a queue, right? As I said, we have created a new node class, right? Let's go ahead and look at the node class, how it's going to look. It's pretty simple. It will have two pointers. One is the original, one is the clone, right? And it's going to store nothing big deal, right? So initially you store the root nodes, original and clone, right? So you store in the queue. That is the first starting point, because that is a root node for a given tree, right? So while queue count is not equal to 0, while queue is not empty, you can assume like that, right? While queue is not empty, we are going to dequeue a node from the queue and see if it is equal to target. For the first case, anyway, we have already done this, original equal to target, return clone. So this will become optional, since we already have something here, right? So this will become optional for the very first node, right? But before even entering into this processing, I am returning right from here. So but anyway, so you dequeue it, and if it is equal to the target, then you return the clone. And what are you going to put the next nodes for processing? So we are doing a breadth first traversal, right? So given tree is a binary tree, you will have left subtree and right subtree, or left child and right child, right? So as long as left child is not equal to null, you create a node and put into the queue. As long as right child is not equal to null, you create a node and put into queue, right? So wherever you encounter the target node as the original node, the corresponding cloned node is the answer. So that is what we are going to return right from here. But for example, if the target node is not there in the original node, right, for original tree, in that case you are going to return null, right? So if you go back to the example 1, the nodes are 7, 4, 3, 6, 19, right? So let's say an arbitrary node called 20 is created and given as a target node, right? It is not even present. In that case, what you are going to do? You are going to return null, right? So that is how it is going to go through this particular algorithm and give you the answer, as long as the node is present in the original tree. If it is not present, it is going to give the null as the answer. So let's go ahead and look at the time complexity and space complexity for this algorithm, right? So for the time complexity, we are visiting each node in the breadth first traversal at only once, right? And moreover, we are processing both nodes parallelly, right? Both trees parallelly. So we don't have to do like one tree once and the second tree second time. So we are doing parallel processing here for both trees. So since we are visiting each node once, right, so it will be the complexity, the time complexity will be equal to the order of the number of nodes in the given tree. So that's the time complexity for this algorithm. And let's look at the space complexity for this algorithm, right? So at a given point in time, we are creating this queue, right? Queue class, queue, which holds the nodes. Nodes have two pointers again. The two pointers are original node pointer and clone node pointer. So at a given point in time, the queue will have the nodes equal to the size of the level, right? So at each level we have 2 power L, assuming that L is the level, right? Assuming that L is the level, right? L is level, right? So we have 2 power L nodes that are stored in the queue, right? At a given point in time, right? So that's the maximum it will hold at a given point in time, more or less, right? So the total space complexity will be equal to the number of levels in the binary tree. So maximum, the worst case space complexity will be equal to 2 power the max level. So we will say, instead of L, right, we will say max level, right? So what is the maximum level that is available? maybe it is 5. In this case, in the example 1 case, so root node it at 0 and this is at 1, this is at 2, right? So the maximum it could store is 2 power 2, that is 4 nodes. So but in the given tree, the node 4 doesn't have any left subtree or right subtree, so it's going to store only 2 nodes, right? So that's how it goes, right? So as long as the max level has some nodes, it is going to store. But since we are talking about the worst case time complexity in case of big O notation, right? So we would say 2 power maximum level that is available in the given binary tree. That is the worst case time complexity. Since Q is not going to hold the entire set at once, that's what we will come up with. So time complexity is order of the number of nodes and space complexity is 2 power the maximum level. And of course, so for each node you have like 2 pointers, right? So you multiply that 2 with, since we are taking that as a constant anyway, so we will say 2 power maximum level, the nodes in the maximum level, that is the size of the queue. So hope that clarified all the questions. If you still have any questions, please leave them in the comment section. I will get back to you as soon as I can. If you haven't subscribed to my channel, please go ahead and subscribe and also share among your friends. Don't forget to click the bell icon. If you click the bell icon, you will get the notifications for all my future videos. Thank you for watching again. I will be back with another problem from Leetcode very soon. Till then, goodbye.